Welcome to part 2 on complex zeros. We're going to now look at conjugate zero theorem, and this shouldn't be the first time you've heard me talk about this. If an imaginary number is a zero of a polynomial function with real coefficients, its conjugate is another zero, which helps us with all of the following exercises. So let's look at example 2. Find a fourth degree polynomial with real coefficients that has zeros 1/2, 0, and 3i. I'm going to note that 3i is an imaginary or complex zero, and therefore it will also have a negative 3i as a complex zero. As soon as I see anything with an I in it, I know that it will have a complex conjugate. And remember, all that a conjugate means is the opposite sign of what you were given. So I can now list all my binomial factors, because remember, all we're doing is we're taking these numbers that are given and saying that x is equal to that number. So now I have x is equal to 1/2, x is equal to 0, x is equal to 3i, and x is equal to negative 3i. Now I just write it as a fourth degree polynomial, so I'll call it p of x, is equal to 2x minus 1. That's my first zero of the polynomial. X, that's my next zero of the polynomial. X minus 3i is my next zero of the polynomial. And finally, x plus 3i. Those are my factors. Now, if we are asked to write this with real coefficients, we are going to have to FOIL the last two binomials, because negative 3i and positive 3i do not have real coefficients. So we have to FOIL this to find out what it will give me. I will have an x squared. I will have a plus 3ix and a minus 3ix, which will drop out. They'll add to 0. And then a minus 9i squared. Now remember, negative 9i squared will simplify to just plus 9, because an I squared is equivalent to negative 1. So this is just a little thing from a previous math class that you need to remember. So my final p of x statement will be p of x is equal to 2x minus 1 times x squared plus 9. Let's go on to example 2b. One of my zeros is x equals negative 1. Note the multiplicity. This is important because once we find the binomial, I will have to square it. Now, if x equals negative 1, that means x plus 1 will be my binomial factor, and multiplicity is 2. So I drop that 2 down as my exponent. The next 0 is 2 plus I, so x equals 2 plus I. But this is a complex zero, which implies that there will also be a 2 minus I. We also need to be careful that for an input of 1, when x equals 1, p of x equals 5. So this is important at the very end. Okay, so if that's the case, we will have p of x is equal to x plus 1 quantity squared times x minus 2 minus I and x minus 2 plus I. I need to remind you that the x minus 2's are very convenient because we can think of them as their own term, and then you just have a difference of squares. So I can rewrite this as x squared minus 4x plus 4 plus 1, because the negative I times the positive I will be a negative I squared, which comes out as a positive 1. So now my polynomial will be p of x is equal to x plus 1 quantity squared times x squared minus 4x plus 5. Now my last critical piece of information that I need to worry about is this p of 1 equals 5. That means I will have some sort of a or constant factor out front that I don't know what it is. So I'm just going to put an a there and try and figure out what that value needs to be so that p of 1 equals 5. And I'm just substituting 1 into the function, so now I have a times 1 plus 1 squared times 1 squared minus 4 times 1 plus 5 will give me 5. So solving for a, so now I have a times 4 times 1 minus 4 is negative 3 plus 5 is 2. So if I solve for a is equal to 5 over 8, 5/8. So I can now rewrite this polynomial p of x in my final form. I'm going to say that p of x is going to equal a equals 5/8 out front. That will ensure that my p of 1 equals 5. And then my first factor, x plus 1 to the second because of the multiplicity 2. And my complex conjugate pair of zeros once FOILed gives me x squared minus 4x plus 5. Let's take a look at example 3. We have p of x equals x to the 5th minus x to the 3rd minus 20x. We need to write it as the product of factors that are irreducible over the rational numbers, which means we can factor out an x. That will give me an x to the 4th minus x squared minus 20. The rational numbers are anything where you can write it as p over q, a fraction, or integer, which is like anything over 1, which is still a rational number. And so I have to stop here because if I were to factor these, the remaining x to the 4th portion, let me just show you what you'll get. We'll treat this as a quadratic because it decreases by half in the degree for each term in descending order. So I'll have x squared is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. If I simplify this further, I get x squared is equal to 1 plus or minus 9 over 2. And so I will have two x squared solutions. My first one will be x squared is equal to 5. And the other solution will be x squared is equal to -4. Let's move on to the next step where we can actually use this information we just found. We need to write the polynomial p of x as the product of linear factors and quadratic factors that are irreducible over the real numbers. Now, this solution, the x squared equals 5, would give me two real numbers. It would give me x is equal to plus or minus the square root of 5. This is a real number. They're just not rational numbers because I can't write the square root of 5 plus or minus the square root of 5 as a fraction or a whole number. And it says and quadratic factors, meaning this x squared equals -4 will not give me real solutions. So I need to leave it in a quadratic format. So now I have p of x is equal to x times x squared plus 4, because that's my imaginary or complex roots, times x plus root 5 times x minus root 5. And now I'm asked to factor it completely. So now we will have p of x is equal to x times x plus 2i times x minus 2i times x plus root 5 times x minus root 5. Now you might be asking me or asking yourself, where did I get the plus 2i and the minus 2i? Well, remember, x squared plus 4, if I set that equal to 0 and then solve for x, I will get x squared is equal to -4. Then I take the square root of both sides, and I will have x is equal to plus or minus 2i. And that's where I got my other two factors. They're complex zeros.